Hello, my name is Eric Bach, and welcome to another session of Techniques brought to you by NEI.
All right, in today's session, we are going to go over how to create a configuration file for Trimble's TerraSync field software, but we're going to build this in Pathfinder Office. Our first step is to go to Start, and we're going to start up Pathfinder Office. I'm just going to choose my icon here, and I'll just open up with the default project that I have set. I'm going to click OK to open the project, and now I'm going to go to Utilities, Other, and Configuration Manager is hidden under this Other tab. So, Configuration Manager, we're going to go to File and New, and it's going to open up several tabs for TerraSync. If you were ever configuring TerraSync in the field software, these tabs will look very similar. And we're going to work top down on this. So the first thing is accuracy settings. The default in the software is horizontal in the field. I get a lot of calls that say, hey, I just purchased this new Geo. It's supposed to be sub-foot accurate, and it won't get below 10 meters. And the reason for that is the most common reason for that is this in the field accuracy. And they don't have a real-time setup, so autonomous GPS is within 10 meters, so that's why they're seeing that 15-foot accuracy. So if you wanted to change it for post-processing, you would change when required to post-processed. You would need to figure out the closest base station to you. Keep in mind the closer the better. Those of y'all using centimeter geos or centimeter with the R2 or some survey gear, you would definitely need a base station if you're post-processing less than 10 kilometers to get that centimeter accuracy. The other thing to check for is the kind of base data. If you're processing, there are still several stations out there, core stations or personal stations, that are only GPS only. They're not a newer device. So the newer ones have multi-constellation like GPS, GLONASS, Galileo, Beidou, etc. So you would need to set that up. In the case for this particular customer, we're going to choose in the field accuracy for our settings there. Another option that Trimble gives you is you can set a required accuracy, meaning if I want to make sure all my features are shot in a foot or better, I can say, all right, use accuracy-based logging, yes. I want to apply it to all features, or let's say I had a data dictionary and I can apply it to a specific feature, like let's say a water meter. I want all my water meters to be 4 inches or better. You can set that up. You can punch in the accuracy. And what happens is it will not let you log the feature in TerraSync until it hits that estimated accuracy. Okay, I'm going to leave this set to no. Going down the list here, we have auto pause vertex count. I actually like this. I usually set it to 10 seconds. And what it'll do is when I shoot the point, after it logs 10 positions, averages 10 positions for me, it will automatically pause the feature. So I don't have to worry about hitting a button. The next big thing here is the antenna and the antenna height. So if you're using a 2-meter pole, you could type in 2M. The next thing, or you could just type in 6.562. Another thing here is you need to specify the antenna. So if you're using a Geo 7X internal, you would choose that. If you're going to be using a Zephyr Model 2, we would want to choose the Zephyr Model 2 antenna. Here we go. All right, and bottom of antenna mount is correct. How often do you want it to ask you for the antenna height? The default is every time you create a data file, it'll ask you, hey, what's the antenna and the antenna height? If you always use the same internal receiver or Zephyr Model 2 on a pole that's 2 meters high, then you could actually tell it never, and it would just skip that step. If you were always adjusting your feature or your antenna height per feature, then you would want to say per feature. I'm going to leave it for the default that's set to per file. Okay, going down the list here, we have other things like log velocity data that is no longer used. That was the older setting that Trimble had years ago. Same with the super correct data, H-star data, etc. We're going to leave all that default. allow position update. So if you had some existing features it loaded in and you wanted to update their position, before you would do that, it would warn you, hey, are you sure you want to update the position? Confirm feature end, same kind of message. It's going to ask you, hey, are you sure that you want to end this feature? It's going to ask you that every time. Next thing in our list is file name prefix. The default is R for Rover. I could put my initials, Eric B, or EB for Eric Bach. Let's say I had more than one device. I could say Unit 1, or Crew 1, Crew 2. It just gives you a file name prefix. You can always go in and change the name of the file yourself. We'll just leave it as my initials. Waypoint, same thing. I just leave that as a W. Between feature logging, the last thing here, this is kind of like a breadcrumb trail. So between your point features or your line features, if you turn this to time and say 5 seconds, every 5 seconds, let's say I shot in a light pole and I'm walking to the next light pole, it will drop a position every 5 seconds. All it stores is XYZ. I'm going to leave this to off. Keep in mind, if you set this to 1 second and you have your sound turned on, you will hear this annoying beeping sound every second. Just a heads up there. All right, so that's kind of the main stuff for logging tab. The next one is GNSS. I leave this default because it's going to set it automatic when it connects to the receiver. In this case, it's going to be a Geo7X. It'll automatically set COM3. You want to leave the smart filter settings on. If you change that, it will degrade the accuracy of your data. We do have some customers that like to output NEMA to maybe a third-party device, let's say a Geiger counter or like a depth finder or ground penetrating radar, things like that. You can set this up to output NEMA. You can set it up to output NEMA at a certain time interval, and then you can check off the specific messages that that device needs. Then you set it up on the port and all that fun stuff. Have a handful of customers that still use that. Everything else in here I'm going to leave default. Next tab over is real time. Some customers just go out and leave choice 1 uncorrected. Means their data they're collecting is just raw GNSS data. Up to 10 meters off, typically it's about 15 feet. But then they come back in and process the data in Pathfinder Office. We do have some other options here. Integrated SBAS is typically sub-meter for the Geo series and the R1 series and the R2 series, depending on the model you buy. Other devices we have can range between 2 to 5 meters. Integrated OmniStar, we only have one device that currently tracks OmniStar. That would be the old Trimble Pro XRT, which has now been discontinued. Integrated beacon, man, I haven't seen that one used in several years. It used to be called a beacon on a belt or a geo beacon or the old Pro XRS, Pro XR backpack units. Haven't seen much out of that in several years now. You could have your own base outputting RTK radio signals. We have a couple customers using that. External source, we'll get to that in a second. RTX is another real-time correction source available on the Trimble R1, R2 series devices. It's a paid subscription. We're going to use external source in this example. And what I'm going to do is I have it selected for choice 1. And then I'm going to scroll down to the external source information. The correction datum. When we start talking sub-foot and centimeter accuracy devices, correction datums and things like units can they really come into play of how accurate your data is or precise. It can throw it off depending on what you check or change a couple feet. So in this case, the customer that we're using here, they're going to have a base station outputting corrections in the NAD 83 2011 EPIC datum. And they want to keep it in NAD 83 2011. So I'm going to keep the correction source datum to WGS 84, which is a zero transformation datum. So it's basically not going to do anything to the data, and the way it's stored in the SSF file, it'll still be in NAD 83 2011. All right, source type. In this case, for this particular customer, he has his own base station. However, we have in the NEI territory probably 5 or 6 VRS networks. Some are free, some are paid. And if you had that type of correction, you would choose VRS. We're going to stick with single base. And then finally, we have this connection method. So most people these days with the mapping equipment will use this internet connection. However, we have a handful that maybe have their own base station with radio, and that way they could use a serial port connection. So at the internet, we have to punch in an IP address. So I'm going to do that for the base station. And I'm going to type in a port. This is very important that you have the correct ones so they match up. If you don't, it may never connect to it will never connect to real time. So just make sure that you have the appropriate settings, and then you go from there. Connection control auto. This is the default. Whenever you start up TerraSync, it's going to automatically, when that GPS connects, it's going to automatically start looking for those corrections from the base station. And after so many seconds, I don't know the exact number, it may be a minute or two, it's going to time out. And then it'll never connect, and you think it's just waiting, but it just times out on you. So I like to change this to manual. That way, I typically start up my internet before I start TerraSync. Then I start TerraSync, I wait till I get at least 4 satellites, and then I hit the connect to external source button. All right, that is it in this particular setup. All these other ones in here, depending on the type of correction that you choose. All right, moving on to coordinates. A lot of people think that what they set here is how it's stored in the data file, and that is incorrect. This coordinate system tab is for viewing purposes only. So if I wanted to see coordinates in, say, a state plane in the field, then I would change my system to, say, U.S. state plane, let's say state plane 1983. We'll choose Georgia. Let's see what we got here. Let's just pick Georgia West, and then let's say we want to see our coordinates in NAT 83. CONUS. So this would allow us to see our coordinates in the field real time. Another thing you have to watch out for is the height. The software has 2 versions of height. We have height above ellipsoid, or HAE. This is the default. This is really just GPS height. And then we have mean sea level, which is what most people are used to seeing. Mean sea level takes the height above ellipsoid and subtracts the geoid model. In this case, the geoid model that I'm using in my TerraSync software right now is Geoid 12A. There is actually a newer geoid model out called Geoid 12B, which has some changes outside of the continental US. I'm just going to leave that selected. And the next thing here is coordinate units. One thing to note in our software, in Trimble software, feet are actually international feet. And typically, if you're working with state plane, you want to use a U.S. survey feet. There will be about a 2-foot difference in a shift if you choose feet over survey feet using state plane. So keep that in mind. I've seen that error quite a bit. Another thing to keep in mind is if you set this configuration file up for a geoid model, when you go to transfer the config file over to TerraSync handheld, it'll say, hey, you're missing that geoid file, do you want to send it over? I recommend telling it no, and you manually copy the geoid file over to the handheld. I will do another video on geoids at a later time. Another reason you would want a coordinate system set up is if you had your own background imagery. Let's say I have a nice image for Louisiana that's in state plane, Louisiana South. I would set that coordinate system up to match in order to view it as a background file. Same thing goes for shape files and things of that nature that you want to load in as a background. Okay, moving on over to units. Again, this is for display purposes only. it's not going to mess with how the file is stored. The file is always stored in latitude, longitude coordinate system for the SSF file. So you would just go through here and set what you want. I will point out here for customers that are using lat long, this is where you would change your degrees, minutes, seconds to say maybe the decimal degrees. So this is where you would do that at. And then finally we have this external tab. These are things like external sensors. So the Geo7X has an integrated laser. So I could say, yeah, let's turn on that laser. The port for the laser is COM6, baud rate's 4800. That would automatically be set up in your data collector. We have other sensors in here that you could set up as well. All right, so we went through all the tabs. You can come in here and lock things down to a password and choose specific ones. Keep in mind, if you forget the password, you're going to be locked out of TerraSync for making these changes, and then you'd have to delete the config file to get back into TerraSync. So you can lock these down. Just if you do write a password, remember it. Okay, finally we are going to go to File and Save As. It's just warning me here about that coordinate system stuff that I mentioned about the geoid model. And we will just save this to, let's say, C drive. And I'll put it in GNSS projects and configurations. So I will call this real time single base and save it. All right, that is it with that one. You can make copies of this and change some settings around if you need. Now we're going to close this out and we're going to transfer this over to TerraSync. So first thing I need to do is change my device type. We're going to connect it up. We have two tabs here. You can always see right now it's saying we want to receive from the GPS to the computer. I'm going to click on the Send tab. Now it's going from the computer to the device. Click on Add, and you will scroll down to Configuration, and here you would see my real-time single base configuration. You can send more if you like. We're going to click on Open and Transfer All. And it'll send that over to TerraSync. I'm going to close that out. I always recommend you use this disconnect button here at the top. If you just hit close, you may get an error next time you connect the GPS that says cannot connect to TerraSync. Basically, you need to restart the computer. Okay, so now what we're going to do is we are going to run the TerraSync software so you can see it. So we are going to connect up. Alright, so this is my Trimble Geo7X. I'm going to go to Start. Actually, I'm incorrect. That is a Trimble 6000. We're going to start up TerraSync. And in this case, since I'm running in the dealer demo, I have 3 levels of TerraSync to choose from. Let's just go with professional. Hopefully I don't have centimeter turned on. All right, so first thing we're going to do is click on status and go to setup. And in the setup menu right in the middle, you're going to have a change button. And here's where I'm going to go to set up real-time single base. I'm going to choose that, hit done. It's going to give me a message about disregarding the current ones. I'll say the current settings, I should say. I'm going to tell it yes. Now, here's where it was asking about that geoid model. I'm going to hit OK. Hopefully it'll let us in because I don't have that geoid model referenced in my TerraSync software at this time. But just to show you, real time, it has external source set up, and we should have all that information that we punched in. There's the IP address, the port, all that fun stuff. I'm going to click on cancel, cancel again. If anyone ever comes in and messes with your settings, you can click on reload and say, yes, I want to reload it. It will wipe everything out and reload based on what you have set up in the change menu. So keep getting that little error message about my geoid model. That's fine. And that's about it. Just to show you the logging settings, horizontal in the field, auto pause vertex, etc. There's all the settings. So that is a quick rundown of the Trimble Configuration Manager. This is very useful if you have more than one device. You want to push out the same settings quickly to say, I have 10 receivers. It's also helpful if you do maybe different types of data collections. Let's say I'm working in Florida. I can use the Florida DOT network. If I'm running in Louisiana, I could switch over to GulfNet if I want to use SBAS. So it's nice to have these different configurations loaded up. All right, well, we appreciate it, and have a great day.
This concludes today's Techniques session. Please visit neigps.com for more videos, FAQs, and information on upcoming trainings. Thank you and have a great day.